We are going to talk about topic 7.1 on inverse function and their derivative. In chapter 7, we are going to learn many new types of function. We call it transcendental function. In order to study the transcendental function, we have to first gain the idea of what inverse function is, and also learn how to take the derivative of this inverse function. Now, what is an inverse function? This is the inverse function definition. Before we talk about inverse function, we have to first mention the definitions of a one-to-one function. One-to-one function is very simple. A one-to-one function is just simply a function such that the value of any x1 that is not equals to x2 will always infer that the function's value at f1 is not equals to f2. Any function that fulfills this condition is called a one-to-one function. That is, you have an x-axis. As long as you pick any two number on the x-axis that is different, then the values of the function at f1 and the values of the function at x2, as long as they are not the same, then they will be known as an one-to-one function according to the definitions of the one-to-one function. For example, y equals to square root of x. Let us look at this very simple function, which is square root of x, where x is defined only for x that is positive. For this kind of function, you know that its function graph is like this. And this is one-to-one because anytime we pick a different values of x1 and x2, the values of the function would be different. Another situation, counter example, would be a sine function. So if you plot a sine function for all the domains of the sine function, what you get is a function that is sinusoidal. Now this is not a one-to-one function because, for example, if you pick two different values here, so here say pi and 2 pi, so sine at pi is 0, sine and 2 pi is also 0. So you have two values, x1, pi, x2, 2 pi. At two with different values of x, the function gives you the same values of 0. So in this case, the sine function for x in its natural domain is not considered as an one-to-one function. However, if you have a sine function that is limited or is restricted from say 0 to 90 degree, and you also consider the x in minus 90 degree, so that the sine function looks something like this. So this is a y equals to sine function, where the x is only allowed to be varying between minus pi over 2 to pi over 2. Then this function of sine that is sort of like restricted to within the domain from pi over 2 to pi, from minus pi over 2 to pi over 2 is considered an one-to-one function. A one-to-one function is very simple to test by using the so-called horizontal line test. That is, if the function is a one-to-one function, then what you can do is that you can arbitrarily draw a horizontal line anywhere in the function, as long as the arbitrary horizontal line that you draw cuts through the function only at one point for all the possible horizontal line that you can draw, then this is called an one-to-one function. A function that is not one-to-one will fail the horizontal line test. For example, you look at the sine function that is defined for all the values of x. Then say if you draw a line here, you find that there are multiple intersections between the horizontal line and the function. Then this function would fail the horizontal line test. Therefore, you can easily identify whether a function is one-to-one or not by using this horizontal line test. If I give you a function and tell you what is the domain of the function, then you can easily tell whether the function is one-to-one. For example, in the case of y equals to x cubed, the horizontal line test says that the function always intersects with the horizontal line with only one point. This could be easily seen to be the one-to-one line test. This is another example y equals x squared, it fails the horizontal line test. These functions of sine and y squared are not one-to-one function. So up to this point, the conclusion is that you have to know what is a one-to-one function, and also how to use the horizontal line test to tell whether a function is one-to-one or otherwise. It is actually quite a very straightforward questions to answer whether a function is one-to-one. However, another thing is that a function may not be one-to-one if you consider the domains of the function to be the natural domain. If you can restrict the domains of the function to a smaller intervals, then you can convert the function from a non-one-to-one function to a one-to-one function. Example would be a sine function, as I mentioned earlier on. If you restrict the sine function to be running from say pi over 2 to pi over 2, then originally the sine function, which is not a one-to-one function in its natural domain, become one-to-one if you restrict the domains to minus pi over 2 to pi over 2.